Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's very hard puzzle, and it's called Liar X Sums Chaos Construction, which is basically all the rules, and it's by Chris Tunet. And here are the rules. We have Chaos Construction, where we need to place the digits 1 through 9 once each in every row, column, and region. Regions are orthogonally connected and must be located by the solver. So, what is an orthogonally connected region? It's basically you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region because you can go from any cell in this region to any other cell in this region just by going through edges, all while staying within the region. Here is an example of a region which is not valid, because even though these two cells can get to each other by going through edges while staying within the region, they cannot get to the other cells in their region by going through edges while staying within the region. They have to go through a corner or go outside the region to do so. And that's an example of how orthogonally connected cells and chaos construction works. We have X sums, where clues outside the grid represent the total of the first X digits in that direction, with X being the digit in the first seen cell. The clue also indicates that the first X cells in the row or column from that direction are in the same region, and that the next cell, X plus 1, is in a different region. A question mark is a stand-in for any digit 1 through 9. Okay, so that means, for example, if this clue was valid, and say it was, well, let's use 25. Say this root clue was valid, and it was 5 in size, then that would mean that this would have to have, you'd have the first 5 digits seen in this direction must add up to 25, and they are in the same region. And then you also know that it stops being in that region if you have this, or past the first 5, right? So this first 5 is in one region. The next cell has to be in a different region then. So that is what an X sum, a valid X sum clue, signifies, right? So basically it looks at the first digit, that's X, and then it says how many, basically the first X digits add up to the number that's outside the grid. So that means the first 5 digits would have to add up to 25. And then those digits are in the same region, while the first digit that's past it must be in a different region. And that's how X sums work in this puzzle. And finally, we have liar X sums, where for each row and column with clues, 2 clues are provided. Only one of them, the top or bottom, or the left or right one, is fully correct. The other clue is lying and therefore totally or partially wrong. So you could have basically this adds up to 5, and this adds up to 29. That could be valid. But one out of that, one of these pairs has to be wrong in some instance, whether it's the sum, whether it's the first X digits are in the same region, or whether the next digit is in another region. It can be wrong in only one of those 3, right? Because basically it could be like, oh, this is the first 5 digits, don't add up to 25. Or it could be the first 5 digits are not in the same region. Or it could be that the 6th cell is not, or the first cell past the first 5 is in a same region as the first 5. So that's what a liar XSum clue could mean, right? It has to be one of them, but it doesn't have to contain all of them, right? So it could have the same value, so the XSum is a valid XSum per se, and then have the same number of those be in the same number essentially of those digits be in the same region, but then you could have like the sixth cell here be part of that region, which would make this a liar XSum, right? And those are all the rules. If you like to play along, and again, this is the question marks are 1 through 9. So this could be sum of 14, sum of 24, sum of 34, etc., etc. This would have to be 1 through 9, this would have to be 1 through 9, and this would have to be 1 through 9. Again, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, I'm not sure how to tackle this. Maybe start with what each XSum could have as the X. 3. Maybe the corners. The corners seem like potentially issues. So 3, you can either have 2 or 3. So this is 2 or 3. Whoops. 2 or 3. And this is 2 or 3. Now this could very well be 2. So you could have 2, 1, and 2, 6. So that would make both of those valid, if that's the case. Or this could be non-valid, right? So this is 2 and 3 is not going to work with 32. And in fact, this one has to be 2 if it's valid. So 2, okay, we're going to make the vertical ones be essentially the corner digits, and the horizontal ones be the digits that's in the middle. So 32. What can add up to 32? It could be 5 or more. It cannot be up to 8. So this is 5, 6, or 7 here. And if there's not 2 of them, we're going to basically use the center one. To add up to 14, you cannot have 2, you could have 3. You could have 4, and that's it. 5 is the minimum of the sum of 5 is 15, right? 1, 2, 3, 4, 5. This is at least 14 here, so this has to be 3, 4. It could be up to 44. So 3 through 8, and the same through this, 3 through 8. For the question marks, it can be 1 through 3. But obviously, any of them could be lying. So, and in fact, going vertically here, it has to be at least, to add up to 26. It could be 4 through 6. Right, because 3 doesn't work, because 3 at most is 3 plus 8 plus 9, which is 20. 4 does work. 6 could work, and that 7 cannot. 29 is 25 and 29. 25 could be 4 digits. Cannot be 3. It could be 5 or 6. 7 digits at minimum add up to 27. So therefore, that can't be that. 29. It cannot be 4 digits because 4 digits at max is 4, 7, 8, and 9. So it's 5 digits at least, up to 7. Actually, does 7 work? 7 does not work. 7 would require... So the digits 1 through 7 add up to 28. But if you have a 7 with it, guaranteed, what digit is going to can go up 1 to give you the 28? You can't. Or 29. You can't, right? 6 would go up to 7, which we already have a 7 in the column. 5 would go to 6, which we already have a 6 in the column. We have all the digits from 1 through 7. So anything going up would basically necessarily double another digit, which is not possible. So this has to be 5 or 6 going that way, if it's valid. 33. 33 would be... 5 at least. 6 and 7. It cannot be 8. 8 digits add up to 36 at minimum. 15 is is 3 through 5. So is 17. Because 15 you can have 5 digits. 15 you cannot have 2 with another digit. But you could have 3. Same with 17. 29 is, again, 5 or 6. That's interesting. 24 cannot be 3, because 3, 8, 9 adds up to only 20. Could be 4, 5, and 6 also works. 7 does not. So those are the possibilities for the possible X sum. So this is 3, 4, 5 for both. Interesting. Okay. What does it imply, though? First X. So we have to sort of think of things as combinations, right? Okay, so say this was valid. That means the first 5 at least would be the same region. That means you cannot have this add up to 8. That means this is valid here. So the first 2 at least would be the same region. That doesn't really tell us much. Okay. Okay, so if this is 32, that means this would have to be 14. That's certainly possible. If this is 15, it's guaranteeing that these are all in the same region. That's interesting. Is there any way then that all of these would be valid? And I think the answer to that is no, right? But it could be none of them are valid, right? So if all of them are valid, yeah, these would be in the same region. They would have to add up to 24, 29, and 17, which is way too large. So therefore, if this is 15, that means none of these One of at least. Well, okay. Can two of them be valid? I think the answer is no. So if the 15 is valid, that means all three of these are in the same region. And 17 and 24 could work. Right? 17 and 24 could work, which would mean that this is valid here. 29 could not work. 29 plus 17 is 46 at least, which, again, a region can only add up to 45 at most. Okay. Can 50... Oh. Okay, there you go. So this 17 cannot be valid. If 17 were valid, these two are in this... Well, okay, that's not true. That's not true. Okay, it's not that easy. If 17 is valid, that means one of these two is a liar. Right? Because then this sum of region would be 15, and this sum of region would be 33, which is too large. It's the same for this. Huh. Interesting. Okay. So even for 8, so if 17 is valid, one of these two is a liar, at least. If 8 is valid, one of these two is a liar, because they add up to 46 also. This adds up to 48, this adds up to 46. If this is, well, this could be just one digit, so we don't know about that. If this is valid, you could have them both be truthful. Um, hmm. um, huh. Huh. Can these ever both be truthful? I mean, they could be different regions. No, they can't be different regions. So both of these cannot be truthful. Because the problem is, they would have to be... This would be 5 at most. This is 5 at least. Which means this would stop here if they're both truthful. This would stop whatever, and these cannot be part of the same region. So that's the problem there. These, however, could both be truthful. So this cannot be, one of these at least is guaranteed to be a liar. Right? Because again, if you try to have, this is at minimum 5 here, and then it stops, and then it becomes another region. This is at maximum 5. Or sorry, this is at maximum 5. This is at minimum 5. This cannot be part of the same region as this, but this, we know this is a separate region. So therefore, this is blocked in. So that's why this cannot work. And it doesn't work for if it's 4 or 3. So one of these two is at least a liar, which means one of these two is at least truthful. They could both be potentially truthful. These could potentially both be truthful. How does that work? If this is, so this is 5 here, and this is 6. then this would be a different region. This could go that way. What's interesting there, though, so we know one of these two is a liar, at least, which means one of these two is truthful, guaranteed. If this is if this is truthful and that's truthful, that means only one of these can be truthful. How would that... Oh, no, this could not... So... Interesting. So then this... How would that work? This is 6, this is 5. So obviously this is not truthful. So since this isn't truthful, this must be truthful. So this must be a region. And no 6 here. So we're assuming both of these are truthful. This has to be a lie, which means this is truthful. So this adds up to 17. This cannot be 5. Well, we don't even know. This has to be truthful, so it's 3 or 4. It could just be, yeah, this is blank. So we know these 3 are the same region. This is false, obviously, in that case. This cannot be the same region. Okay, well, we already know that's false, too. This could be the same region. Oh. That's interesting. This has the same issue, right? If you have both of these be true, this is only 5 at minimum, at most. This is 5 at minimum here. So if these are both true, this is 5 at maximum, 5 at minimum. This is blocked by another region, therefore this would not be a valid region. So one of these two has to be false, which means one of these two is true, guaranteed. But you could have a 1 there. So if, again, this is fully valid, it has to be 6, this has to be 5. We'll make that dark and then medium. This has to go there. We have this being there. So if both of these are valid, these are invalid. That means this has to be 6. So this is false. Since this is false, this is true. Which means this has to be false here. Which means this must be true. So then this would be 1. Because you can't have any other sum up to be in the same region, have a different region there, and then add up to the single digit. So no 1, no 6 there. This would be valid, so we have at least 3 there. This is not valid, so we don't have any information there. This cannot be 2 or 3, so this is invalid. which means this must be valid here. So this must add up to 24. It could be the same region as this, so that could be valid. Um, 33 I don't believe works. If you have 33, that means this would be the same region. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. So this is invalid, which makes that valid. So these are part of the same region. You could have 15 here. That could be certainly valid. This would not be 6, obviously. This would be 5. So this could not be 5 here. It has to be 3 or 4. This is invalid, so we can remove that. This is invalid, we can remove that. This is valid. These are invalid. So these add up to 26, which means these must add up to 19. Because 45 minus 26 is 19. These would add up to 16 here. So these would both be invalid. You could have 2 or 3 going that way. So far that looks fine. Okay, so the question is where do we invalidate these then? 17. So if we had 3 here, that means the remaining digits must add up to 14. Because 17 minus 3 is 14. But then we need 5, 9, or 6, 8 here, and we already have 5 and 6 in the row. So this would have to be 4. Interesting. So if we try to go there, this can't be 4. It's 5 or 6, and therefore they cannot be the same region, which means that would be false. So then this would have to be true. That would have to be true. This is a separate region. Then this is a separate region, and it's 5 at least. These are not the same region, so this would have to be the valid region here. And it would be 2 or 3. It's probably part of blue. So this would be 4. This would be a completely different region. It has to go this way. This is a completely separate region because this is at least 5 now. So 4 to add up to 17. The remaining digits must add up to 13. So it could be 139, 238. I think those are only ones, right? This is 5 digits or 6 digits adding up to 24. So this could all be the same region here. And we know that's a different region, so that has to go that way. We don't know if it's part of this. Can it be? 1, 2, 3, 4. So this is either 139, 238. I think that's it. You can't have 4, 5, or 6, right? You can't have 7, 8 together because that's too big. 15 for 13. 139, 238. You can't have 1, 2 because that's too small with another digit. So you guarantee that this is 3. So this would have to have a 7 here. This is at least 5. It cannot be 7 here. So this is the same region. So this would be... Cannot be 7 because that would be too large of a region. So then this would have to be 6. So this is 5 or 6. This is 3 or 4. So this is 5 or 6, and this is 5 or 6, which eliminates 5 and 6 in the rest of the box. Or column, sorry. This can't be 4. We don't know if this is the same, if this is valid, right? Can this ever be a 4? Maybe. This is not valid, so we don't have to worry about that. This is valid this way, because this cannot be valid. Because both of these are correct in that instance. So far this is looking okay. You could have 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is possible. We don't have to extend here. It could just be all 9 there. So this is 17. This is 11. That's 28. 45 minus 28 is 17. So if that's 17 here... Oh, this cannot be the same region as this. If we had that as the same region... Right, so this is 17 here. This is 11, that's 28. 45 minus 28 is 17. So the remaining digits are 17. So they're either 719 or 728. But 17 plus 29 is 46. So therefore, this cannot be the same region as this. And if we try to have it as the same region but something in between, then this blocks it. So this has to be a different region, interestingly enough. Which means it must exit out. So it has to go something like that or something like this. These are different regions then. So far this is looking okay though. This is 7. Remaining 4 digits must add up to 26 minus 7, which is 19. So we have 7 here with 1 9 or 2 8. So far that's looking okay. Okay, well, I don't know. This feels kind of like the solution path, so let's not go down this path too far. What happens? So what happens if both of these are true? If these are both true, these are false. So we don't care about that. We don't care about this. These are both true. These are part of the same region, guaranteed. This must be 2. That must be 1. This could still be valid. Interesting. So then you cannot have 1 or 2 here. And we know one of these 3 is valid. It cannot all be all 3. These 2 cannot have... So one of these 2 must be valid, which means it says 3. So one of these 2 is valid because both of these cannot be valid. So one of these is a 3. That means this is invalid, which would make that valid there. So we know this is all the same region. If we try to have 2 and 6 here, does that work? No. 6 digits cannot add up to 25 without 1 and 2. Right? 3, 4, 5, 6, 7, 8 basically adds up to 3 and 8 is on the ends, so that's 11 times 3 is 33. So this cannot be valid here. So that's invalid there. Interesting. So if these are both valid, this cannot be valid. Huh. So this is not 6, it's 4 or 5. Can you have 5 digits add up to 25 without 2 or 1? 3, yes, 3, 4, 5, 6, 7. Okay. So this is invalid, which means this is valid here. So these 2 are the same region, which means one of these is invalid. Interesting. That means this is valid here. The thing is, this can't be the one that's valid. 33 plus 24 is what? 33 plus 24 is way too large. Um... 33 plus 24 is 57. You can only subtract out 1 digit, which would be 9 at most, which is 49. So that 57 minus 9 is 48, which means the rest of the region would have to, without the 9, would add up to 48, which is too big. Or, I mean, the region with the 9 would have to add up to 48, which is too big. So this is not valid, which means this would have to be valid, this would be invalid, and this would have to be valid here. So this would have to be the same region, I guess. So you have that the same region, that the same region. So this is valid, so it's at least 3. So far, though, it's looking okay-ish. We know this is invalid. We know this is invalid. This is valid. It cannot be 2 and whatever. So this must be 3, which makes this 4 and 1. So that's part of the same region. So then this would be red. This would have to be yellow. This could not be 3. Interesting. One of these is invalid. So 4 going down. So this cannot be 6. If it's 6 going this way. Oh, this fails. So this cannot be 4 and 5. Right? Because this is 24 at basically total. This is 15. 15 plus 24. So you can't have 5 and then 4. This is guaranteed. So since this is guaranteed to be 3, this has to be all 9 digits if this is 4 and 5. But that's going to add up to, at most, 39, and not including, already including this cell twice. And that's too small of a sum. So this cannot work. One of these is invalid. Is it the 3? The 3 might be the one that's in... Okay. Hold up. If this is valid... Interesting. Well, it's only because of 2 and 1 there. If this is valid... So if this is valid, that means this cannot be 5, 6, or 7. So this is invalid. Oh, that's interesting. So if this is valid here, obviously this is invalid. That means this has to be at least these digits. This must be invalid, since this is invalid here, because this can't add up to 32 with 3 digits at most. This must be valid. Since this is valid, this cannot be valid because, again, it's too... This is 5 at most here. This is 5 at least here. Then this changes to a different region, and therefore this can't be part... This must be part of this region, but it's too large as a region. So therefore this must be invalid, which means this is valid. So if this is valid, it cannot be 2 and something. It must be 3. So you're guaranteed this is 3, 4, and 1. Obviously, this can't be 3 anymore. No 4. This is valid here, then. So we have that. This cannot be valid in that instance. So if this is valid... this is valid, this is invalid. This is at least... This is 3. Which means this cannot be 3 here. It's 4 or 5. So this has to go down that way. It can't be 5. Because if it's 5, it has to have all the digits 1 through 5 there. So this can't be 3. This cannot be valid, because if that were valid, it would be 5. It can't be... It would have to be part of this region. And so couldn't have a 4. This would have to be 5 cells. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10 is too big. So then this would be invalid. This would be valid here. This cannot be 5 for the same reason I said, because it has to be 1, 2, 3, 4, 5. So this is 4. So this would be 4 going that way. Obviously, this couldn't be 4. This can't be 4. So these digits would have to add up to 15. So this would be a different region. Oops, this would be red. This could not be red. If that's red, this would be too large of a region, because this would have to be the same region then. So this would be green. Green has to go out. That would validate that. This is 3, 4, 1. This obviously could not have a 4. So this would have to be valid, which means it's at least 3. Uh, could this one be valid? Hmm. Interesting. So this is interesting. This is guaranteed to be true in this instance, then. It could be 14. This is no longer valid, so we don't care about that number. We don't know about these two. Obvious. Well, not obvious. Could these both still be true? I think the answer is yes, right? 6 here and 5 here. But then this would be true also. Okay, well, yeah, we also know this is not valid. But then the problem is... Yeah, one of these has to be false. Right, because you have 6 here. Obviously, this is false, so this must be true. So if you have 6 here, one of these has to be 1. This is true. So this can't be true. It's false. But the problem is 6 and 1 forces this to be false. Because it can't be 1 anymore. This is 5. So that's assuming that both of these are true. So one of these is false. If you have... Well, you don't have to have 6 in that case if one of these is false. Huh. I mean, it seems kind of valid. Okay, well, how do you add up to 14 with 4 digits without 1 and 3? The answer, I think, is no, is you can't. Right? 3, okay, so minimum then is 2, 5, and 6. Yeah, it's too big. 13 plus 4 is 17. So this is invalid. So you can never have this be valid. Okay, well, there you go. So that's helpful. So that means this is always invalid. This is always invalid. This is always valid. Which means this has to be 2 or 3 here. So 2 or 3 cannot be here. This is 5, 6, or 7 if it's valid. We don't know if it is. Right, and the reason why we know that is if this is valid, this is 2 or 3, that means this can't be valid, so this has to be valid. But we know if this is valid, this can't be valid because of the way that the geometry works. So therefore, since this is invalid, this must be valid. It has to be 4 because this can't be 2 and 6 here, adding up to 8. It has to be 3, therefore that's 4, this is 1, and therefore this can't add up to 14. in the same region because we don't have 1 and 3 available. Therefore, the lowest next is 2, 5, 6, which is 13, plus 4 is 17, which is too large. So therefore, this is valid, which means these are the same region. So either it's 2, 6 here, or it's 3 with 1 or 4. So this can never be a 5 here. So it's either 2, 6, or it's 3, 1, and 4. We don't know. So we definitely have a 2 or 3 here, which means one of these has to be false. Which means one of these has to be true. Okay. I think one of these has to be false here. Yeah, so if this is true, if this is true, that's 2 and 1 here. That means this must add up to 8, so it's 2 and 6, but 6 digits can never add up to 25 without 1 or 2. So therefore, this would be false, this would be true in that instance. And if obviously this is true, it's 4 or 6 here, but again, you can't have 2 and 1 here, adding up to 3, so then this would be false. So at least one of these is false, which means one of these has to be at least true. Interesting. It could still be both are true. Don't know if this is 3 or if this is 2. If this is 3, then both of these are false. Well, you could have 4. Maybe. We know one of these 3 is true, so it has to go at least that. You could technically have both of these be true. Technically. Interesting. If this is 314, this has to be false here. So let's try that. 314. We don't know this is blue. How did I color that blue? I don't know. But we're basically saying this is 314, adding up to 8. Therefore, this can't be 3 or 4. Therefore, this is false, which makes this true. That's interesting. Therefore, this can't be true. That's false, which makes that true. So this is the first 5 digits at least. This has to be the first 5 digits at least. Oh, that's interesting. Huh. Very interesting. Huh. Obviously, none of these can be 3. 33. Could potentially... No. Could it work? 33 plus 17 is 50. If you subtract a 5, that could potentially work. The problem with that. The problem with that is this has to be 5 in length also to match. Because we have all the sum already adding up to 45 here along this row in this column. But this can't be 5, so we only have 4 of them. We need an extra digit here, but then that would add too much to this. So then if this is okay, so part of it is assuming this is valid. If this is valid, this has to be invalid. Interesting, which makes this valid. We already know this is false, so this is false, which makes that true. And that's going to be 1 or 2 anyways. Oh, and then we have a contradiction. Because this is invalid, this must be valid, and it can only add up to a single digit. But then this can't be valid. So that's a contradiction, which means this cannot be 3, 1, 4. Because that would invalidate that, which would make that valid, and that valid, because this can't both be valid at the same time. And because of that, this is invalid, which makes that valid, but then this has to be valid because it doesn't add, this would add up to too big of a number for the region. So this cannot be 3, 1, 4 here. This has to be 2. So we know that for certain. So this has to be 2. So this is 2 and 6. That means this can't be 6 here. So let's, again, try to see what happens if we validate this. So none of these can be 2. So again, one of these has to be invalid at least here. If we invalidate this, so this is wrong, this is true, that means this has to be false, because again, you can't have, these would have to be part of the same region, and they would add up to too much, so this would be true. So we have that, we have this. And you still can't have this, so this is still invalid here. In that instance, right? Because if you try to have these part of the same region, or same region adding up to 17. The problem is this adds up to 33. I guess this could be 7, though. So the previous one, we knew this was invalid, so this had to be valid. But that would invalidate that, and then you have that being valid. Well, okay, maybe this could be 7. Ooh, I forgot. I didn't think about that through. Let's try that then. So what happens again? So let's go through that again. 3, 1, 4, 1, 4. This can't be 3 or 4, so this is invalid. This is invalid because it's 3, and 3 digits are never going to add up to 3. So this must be true. This is invalid, so this is valid, which makes this invalid, which makes that valid. So we have 5 here. This is valid. So therefore, this must be 4, 5, or 6, which means this is invalid, which means this is valid. Oops. Green. So it has to be at least these. Okay. Can this work? I think the answer still is no. Obviously, 5 doesn't work. Because then you have 17 here, 33 here, that's 50, minus 5, so they must add up to 45, but since this is 5, this would be 4 in length at most, which means that's 8 cells in the region. which is never going to add up to 45. What about if this is 6? If this is 6, this has to be guess it could work. Hold up. If you have 6 here and 4 here. Can you have 3? 3, 6, and 8. So this would be size 6. I think the answer to that is no. This cannot be 3. It's 1 or 2. No 6, no 6 here. So this is 4 or 5. So this means this being true and not being 6. Well, we don't even know if that's 6. Okay, let's try 7 first. If we have 7, that means this has to be 3, and I don't think that works. 3, 7, and 7. No. Right, because this is 9 already cells here. So that's why this had to be 3. And that's 3, 7, and 7. So 7 does not work. 5 doesn't work. 6 maybe does. So no 6 here. No 6 here. This would have to be 4, 5 at most. This would be 5 at minimum if these were both true. So this would have to be true here and false here. Because it would add up to 55 as a region if that were the case. Therefore, this is true. It must be 4. This is 1. 25. So that means the remaining ones are... so we don't care about that. We know this is 4, 5. No 3 here. No 3 here. This cannot be 14. So this is not valid here. Because we have 1, 2. This is 3, 1, 4 here. This can't be 4. It would be 5 at least if it were valid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's too big. So this would have to be valid, but then we already know this has to be the same region. So we've proven this can't be 3, 1, 4. There we go. So what does that show? That shows this has to be 2 and 6. So this has to be 2, that's 6, and we have a boundary here. Oops. So this is a hard boundary. This still could be 2 and 1. We know 2 cannot be any of these. Can you have... Well... So that means this can't be 6 here. Can you have 6 digits here and be valid? Okay, so we know this can't be 6. That's interesting. Six digits adding up to 25 with a 6 and without a 2. That's 19. You could have 1, 3, 4, 5... No, 6 digits. 1, 3... So that means without a 2, the minimum is 1, 3, 4, 5, 7. 3 and 7 is 10. 1, 4, 5 is 10. That's 20. 26 does not add up. So this is not valid, which means this is valid. So this is valid. This must be 5 in size. Interesting. Which means this can't be 5. So this is the same region. And this is a different region. So this is a boundary. Okay. This cannot be 5. This can't be 5. Interesting. How else do we tackle this? Okay. So one of these can only be valid. Either it's all 1, this is all the same region here, or one of these is 3 going this way. So 2 out of these have to be true. And it cannot be these 2, right? Because if it's both of these, this is going to be stuck at 4. This is at 5, and they would have to be part of the same region, which adds up to 46, which is too large. So it cannot be both of these be true. Therefore, this is true here. We need 2 trues here. We can only have 1 true here, right? Because you can only go 1. If this is... Well, hold up. You could have 3 here, and then this be 1 and be part of a separate region. Oh, no, that doesn't work. So okay, so either this is true or this is true. If this is true, that means this must be a full region by itself, and it's 6, because it cannot be with the 5 here. So if this is true, it has to be a full region, cannot be part of that. So only one of these is true because you have a 1 here, which limits, which basically is valid. And all 3 of these can't, well, these 2 cannot be true at the same time. So therefore, this is true. If this is not true, this is true here. So that must be 2 and 1. But then only one of these could be true, right? You can't have a 1 here to match this. You can't have a 2 here to match that. Only one of these can be 3, which adds up to a single digit. So then, again, 2 out of these must be true. Again, both of these can't be true at the same time. So this is guaranteed to be true, which means this is false. So we don't care about that. This is guaranteed to be true. 1 out of these 2 is guaranteed to be true. We don't know which. This cannot be true. If this were true here, this would be way too big of a region, right? 24 plus 33 is 57 minus 9, because you're double counting it, would still give you a value of 48. So this cannot be true. So this is false, which makes this true there. So this is true, which means this has to be false because, well, actually, it doesn't have to be. Never mind. We know these are valid. So this is false. One of these has to be true. So it's either 1 or it's 3 something whatever. So if this is true, then it's 6. So if this is true, this is 6. Okay, so we know this is false, so we don't have to worry about that. This is interesting. I don't think this can ever be 7. No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is too large. So this could only be 5 if it's true. Um, oh, I made that blue. I don't know. That's green. This is true. So this adds up to 29 with, okay, and then this adds up to 16 without a, with a 6. So that means to add up to 10 without 5 or 6 available. It has to be 127 then, right? The possible 3 digits adding up to 10, right? 45 minus 29 is 16. 16 minus 6 is 10. So 127, 136, 145, or 235, all of 3 of which require 5 and 6. So this must be 1, 2, and 7. Interesting. That leaves this as 3, 4, 8, 9. Okay, there we go. So, if this is 2, 1, that means 3 has to be here, and it must be valid, because again, all 3 of these can't be false. So one of these has to be true, which would make this 3, 5, and 1, but we already have a 3 in the region here. Because this can only be 1, 2, 7 here. So this cannot be true here. Because that's 2, 1, that would force 3 here. That must be 3 is valid region there, which means that can't be true. So this cannot be true, this is false, which forces this to be true, and my intuition that both of these are true is correct. So this has to be 6, size 6. It's fully in that region. It must go out this way. This is a boundary here. So this can't be 6. This has to be, so this is invalid because it's 6 there. 6 digits are never going to add up to a single digit. So this must be valid here. This is invalid here. So this is done as a region. We don't know about this, though. So this is valid as a region. This must be a 1. So this is valid. This must go 3 or 4. Can't be 3 because of the same problem that we had earlier. So this is 4. This cannot be 4. This is, we don't care about this. So again, this is 4 in size because we tried to have 3, but that makes this add up to 14 for these 2 digits, which means it requires a 5 or 6, but we don't have 5 or 6 available. So again, this must be 139 or 238 here with a 3 there. This must be 179 or 278. And again, these cannot be all medium. This has to be light here. And this must be light here. This is a boundary. This is a boundary, and this has to be pink at least. Or I guess we'll make this orange. We'll make this dark, and this will make medium. So medium has to exit out somewhere. So we have this. We have a guaranteed 3 here. Oops. Guaranteed 3 there. Guaranteed 7 here. And that's another reason why this can't be all dark. If this was all dark, then we have a guaranteed 8 and 9 here. Okay, so 1 is here, which means this can't be 1. So that's 2 or 7. This can't be 4 anymore. We know this is valid. This cannot be valid. If this were valid, the problem is you'd have to, this is guaranteed to be at least 5. That's the reason why. So you have 5 and 4. This would then not add up to 45 because this 15 and 24 adds up to 39. So that's why this cannot be valid. So this is not valid, which makes this valid. So this has to be 5. Interesting. So this is 5. This cannot be 5. It's 6 now. So green goes this way. Medium has to get out. So medium has to go to these two. So this is boundary, this is boundary. That means light, 1, 2, 3, 4, 5, 6. It has to be, yeah. So this is either medium or dark. This could be medium, light, or green. And this is light or green here. So this is 6 digits adding up to 24. Which means the remaining digits add up to 21. So it cannot have 3 here. You could have 4. So this is 6. No 5 or 6 here. This is 32. This is 5. So this is different region. 26 here. That means these 3 add up to 19. So it has to be 2, 8, 9 here. So then this is 3, 4, 5, 7. Right? 1, 3, 4, 5, 6, 7. So 3, 4, 5 is 12. 1, 6, 7 is 14. That does add up to 26. So this is 8, 9. This can't be 7, so this is 2. So no 2 here. Can this add up to 14 here? You have guaranteed 8 and 9. Well, one of them has to be 8. So I guess you could have 3, 2, and 9 here. That could work. 7 eliminates 7 here. So this could be 14. This could also be 14. So if this is 14, this is 3, 2, 8. Sorry, 3, 2, 9. If this is 14, it can't have 7, and it can't have 8. So if this is 4, if this has a 4, it's 14. It's 3, 2, it has to be 3 digits here. If this is 14, which it can only be, it could have to also be 3, 2, something. So this would be 3 in that instance. This would be 3 in that instance. That's interesting. Right. So these cannot have 1, 3, or 4. It's 2, 5, 6, 7, 8, 9. The 7 has to be one of the lights here. So this can't be 7 here. This is 6. So 21 here. So 3 does not work here. 3, 8, and 9 is 20. 4 does work here, which means this can't be 4. So you have 4, 8, 9, 8, and 9. 5 could work. 5, 9, and 7. And you could have 7, 8, well, no, 6. So 7, 9, and 5 there are possibilities. Interesting. Okay. Why does there seem to be like a line there? That's weird. This adds up to 32, so this must add up to 13 here. So that's 1 and We have 10 here. It must be 1 and 2. This can't be 1 because of 1 in the row, so that's 2, which makes that 1, which means we know exactly what these are. These are 3, 7, 8, 9. Can you have 3 then, adding up to 14? Without 7, 8, or 9, or 5, it would be 3, 4, 6 at maximum, which is 13, which does not count. So this cannot be the valid. So this is not valid, which means this is valid. So this has to be 3, 2, and 9, adding up to 14. This is a boundary here, and then we have an 8 somewhere. So 3 cannot be, 3 cannot be any of these. 3 cannot be here. This can't be 9. So this is not valid. 9 cannot be here. This is either 4, 8, 9, or 5, 7, 9. It cannot be 6, 7, 8 because of the 6 in the row. So we have to have a 9, which means 9 is there. So no 9 here. We have to have 8 as one of these two, because it stops after the 3. So one of these is 8, which means this can't be 8, which means this can't be 4. This is 5, 7, 9 as a triplet. It's add up to 21, which makes this 1, 2, 3, 4, and 8. So 2 cannot be part of this green region, which means that's light. So this cannot have 2 here. There's no 2 here. Oops. No 2 here. 1 cannot be part of this region. So we have boundary here. We have boundary here. This, I guess, will make pink or something. It cannot be part of red. It cannot be part of yellow, because if it is yellow, red gets blocked. 1, 2, 3, 4, 5, 6, 7, 8, 9 would mean red is a 5-cell region. 7-cell region. So 6 needs access to 5, 7, and 9. And only one of them can be here. Okay. So the medium has to go out this way. Dark has to go out this way, so this cannot be 8. Because there's not enough space for dark. Medium has to go out this way. Dark has to go out this way. 1, 2, 3, 4, 5, 6, 7 at most. 8, 9. So this is the minimum for medium. We have 1, 2, 3, 4, 5, 6, 7. So, whoops, we don't know that. We do know all of this is boundary. We know this is boundary. This has to be 8, because we need access to an 8, which makes this 9, which makes that 8. This can't be 8 or 9. There's no 8 here. Blue has to get out. This is orange. So blue has to go here. This is a separate region, so it's probably yellow. This can't be orange because orange is done, so this must be all blue. Blue still has to continue out here. So blue goes to here. We have 3, 4, 5 possibility here. And blue could go here or here. Yellow has to continue out here. Yeah, can't be dark, can't be... So dark has to go out here. Dark needs access to a 7. So it has to be one of these two or here. We have... Remaining digits in dark are 1, 2, 6, 7. Obviously 7 can't be there. No 8, 9 here. Okay. This is almost certainly yellow. Red needs access to 1, 2, 4, 1, 2, 4, and 6. Okay. So this is 13, 32. That's fine. 14. Huh. This cannot be part of blue. It cannot be part of red. It cannot be part of dark. It cannot be part of medium. It can't be part of green. Light is all here. This digit... Okay, so remaining digits in row 2. 3 through 9. Okay. No 7 here because of 7 in the column. This cannot be 2 and 8. It's 1, 3, 9, which eliminates 1, 3, 9 in the rest of the row. So no 1, 9 here. It's 2, 7, 8 here. This cannot have 9 in the light region. This is different region. Green needs access to 2. It only can go 1 here at most. Obviously cannot be green, green. If it were green, green, well, no, it needs access to a 7. So it could be green, green. What happens if we go green? Okay, cannot be green, green here. Right? If it's green, green here, this is pink. Red would have to go... Well, yellow still could do that. That actually... No. Green, green forces this to be pink, and then pink has to go here, and then we block red. So that does not work. So this cannot be green, green. That means this is guaranteed to be green. So we have guaranteed boundary there. You could have green here if you go pink, pink there, and red, red. You could go... Okay. So I think this has to go... Okay, so because of this has to go pink. Right. If we have pink, red trying to exit out. So that must be pink and red exiting out here. So that means this must be 3 in size. We have boundary here. This is 3. It must be 5, 9, or 6, 8. Adding up to... No, it's 14. Never mind. So it's... That's a lot. Okay, 3 is here, which eliminates 3 in the rest of the column. Red has to get out. Pink has to get out. Red can't be full 9 here. So red has to get out. Pink has to get out. So pink has to go this way, which means this is green. Because we need access to 2 for the green. And then we have 1 more here. That means this is a combination of light and green. This cannot be medium. So medium has to go... This can't be dark. This is medium. 1, 2, 3, 4, 5, 6, 7, 8, 9. Dark has to go out here. 1, 2, 3, 4, 5, 6, 7, 8. And then could go either way. Pink has to go that way. Red has to go this... Well, yes, pink has to connect here. That means red has to go out here. So that's 5, 6, 7, 8. 1, 2, 3, 4, 5. So this is done. This is definitely boundary. This is boundary. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's done. Red and pink are valid there. This must be part of yellow. To add... Okay, so these digits are all part of yellow. Because they can't be red, they can't be pink, they can't be medium or dark. So we have that. This has to be what? 1, 4, 7, 8, and 9. No 8, 9 here. That means this cannot have 1, 4, 7, 8, 9. It has to be a 5, 6 to add up to 14. To add up to 11 with the 3. So that means we need a 2 left. This is 5 and 6, which eliminates 5 and 6 in the rest of the column. 4 cannot be in the green or medium. So this can't be 4. The green has to be 5, 7, or 9. No 7 here because of 7 in the column. 2, 7, 8 eliminates 2, 7, 8 in the rest of the dark region. No 7, 8. This can't be 7. It's 5, which makes this 7. No 7 here. That means this can't be 5. Rest of the dark region, then, we need a 1. 1 can't be here because of 1 in the row, so 1 has to be here. The rest, then, are 3, 4, 6, and 9. That means where's 2 in row 4? It has to be here. So that eliminates 2 here. Okay. This digit, so is 1, so 1 eliminates 1 from being here. This is 2, 6 as a pair. That leaves this as 1, 7. We need another 1, 7. It's one of those two. Okay. So blue can get to one of these two. Because we have 8 cells, we need a 9th one. We have 1, 2, 3, 4, 5, 6, 7. Dark can get to one of those two. Yellow can be any of these 3. We have 8 reds, so red can be any of these 2. And pink can go 1, 2, 3, 4, 5, 6. We could go 7, 8. So it could go to any of these, potentially. Well, no. Can't go to here, because then that would block off red. Cannot go to here. Well, it could go to there. Could go to here. Blue could go here. Dark could go here. So these could both be pink. So this is guaranteed to be pink here. Interesting. So dark can only get to here. Blue can only get to here. Yellow can get to here. Red can get to here. So this is pink. So we have 1, 2, 3, 4, 5, 6, 7 guaranteed pinks. Obviously, it's connecting one of these two. But then it can connect to any of these 3. That's fine. Okay, remaining reds have to be 1, 2, 4, and 6. This can't be 2 or 6. This can't be 2 because of 2 in a row. Pinks have to be 3 through 6, and then 8, 9. No 3, 5, 6 there because of 3, 5, 6 in the column. Where is the 7 in column 2? It has to be here. So this is 7, which could be light. Actually, it has to be light. It cannot be green. If it's green here, light also needs a 7, but this 7 would eliminate all the 7s from... It eliminates 7 from the rest of the row. So this has to be light, which means the green 7 has to be here. So this is 7. No 7 here. Okay. This has to be 3, 4, 5, 6, 8, 9. No 8 and 9 here because of 8, 9 in the row. This can't be 9 because of 9 in the row. One here eliminates 1 here. What is available? Okay, so we have 5 or 9 here. The other 5 or 9 is here. But we have guaranteed 5 for the light region in row 2, which means that cannot be 5 for the green. So this has to be the 5 for the green, which makes this 4 and 5. There's no 5 here. This can't be 6 because of the 2-6 pair in the row. 5 eliminates 5 there. And no 5 there. So this must be 5, 9. You cannot have a 3 here. And so the light is missing 6, 8, and 5. The green is, so this is 5, 6, 8, and 9, which eliminates 5, 6, 8, 9 in the rest of the row. So this is 3, 4 as a pair. 4 eliminates 4 here. This is 3, 6, 9 as a triplet, which eliminates 3, 6, 9 in the rest of the region. So this is 4, that's 3, which makes this 8. That's 4. So no 4 here. No 9 here because of 9 in the column. 4 eliminates 4 here. 5 eliminates 5 here. This is a 3, which eliminates 3 here. No 3 here. That eliminates 3 here. This is 6, which makes this 2 and 6. So no 6 here. 2 eliminates 2 here, so it's 7, which makes that 1. No 1 here. No 7 here. Okay. We have 1 and 7 remaining. 3 eliminates 3 here. Remaining digits in... Let's do row 6 for now. So we have no 1, 2, 3. So this is 4 through 8. If it's dark, it's 7. If it's pink, it could be any of these. Okay. Remaining digits of row 7. 1 through 7 here. This can't be 6. That eliminates 6 here, so that's good. No 7 or 5 here. Red can only have access to 1, 2, 4, 6. Yellow can only have access to 2. So this is 1, 2, 4, 6 here. This can't be 7 because of 7 in the column. No 7 here because of 7 in the column. Yellow or pink? If it's yellow, it's 2. If it's pink, it's 1, 3, 4, 5, 6, 8, 9. There's no 3 or 8 here because of 3 or 8 in the row. No 5 here because of 5 in the column. And... blue, dark, and pink all have a 2 already. So this cannot be 2. That's it. So 2 in column. This digit can be 2, 4, 5, 6, 7, 9. Okay. So that's pretty broad. Okay. So again, I'm pretty sure all the x sums are valid. So 139 is 13 plus 4 is 17, and that's 4 digits. And then it's another region. 5, 3, 9, 8, 4. And we have to show that this is invalid. 6 cells is not in the same region, so that's fine. 2 cells adding up to 29. Sorry, 2 cells cannot add up to 29, so that's invalid. 1 cell adds up to 1, which is valid, and it's a different region there. 6 cells, 1, 2, 3, 4, which is 10, plus 6 and 8 is 14. So 10 plus 14 is 24. This is a different region, so 6 cells is valid. 7 cells in the same region, that's not valid. 4 cells in this, there's 7 or 8 cells in the same region, that's not valid. 3 cells in the same region adding up to something 4 is 14. That's valid. 2 cells adding up to 8, 2 and 6, which is the next cell in the different region, is valid. 5 cells adding up to 8, that's not valid, or in the same region, that's not valid. 2 cells in the same region, or adding up to 3 is not valid. 6 cells in the same region, not valid. 6 cells adding up to 26, again, 3 and 7 is 10, 4, 5, 1 is 10, 10, 10, and 6 add up to 26. And this is a different region. 5 cells in the same region, adding up to 29. 3, 4, 5 is 12, plus 17 is 29, and this is a different region. 3 cells adding up to 14, 3, 5, and 6, with this being a different region, is valid. 1 or 9 cells is not valid. 4 cells in the same region is not valid. 5 cells in the same region adding up to 32, which is 5, 7, 8, and 9, which is 29, plus 3 is 32. So we've got all the liar X sums validated or invalidated, depending on the circumstance. So now we just need to figure this out. Oof. We have 7 as one of these. Oh, 7 cannot be in pink, 7 cannot be in blue, 7 cannot be in yellow. So this can't be 7. Okay, that's not helpful. If it's this way, this is 7 and that's 1. If it's this way, this is 1 and 7. So 1 can never be here. Okay. In this column. Because if it goes this way, that's 7 and 1. If it goes this way, this is a 1-7 pair. Two is one of these 3 here for the yellow. 2 can be either one of these 2 for the red or one of these 2, obviously. 2 in green is one of these 4. 2 in dark is one of those 2. Oh, we need a 5 somewhere in row 6. And this can't be 5 because it's in the red region. This can't be 5 because 5 in the column. This can't be 5 because of 5 in the dark region, and these are all filled out. So this has to be 5, which cannot be dark. It has to be pink. So then we have 5 for pink. No 5 here, no 5 here. This is 6, 8 as a pair, which eliminates 6, 8 in the rest of the row. So we have 1, 2, 3, 4, 5, 6, 7, 8 pinks. So this can no longer be pink, which means that's yellow, which means these can't be yellow. So this is red here. That means this can't be red here. That's pink, which means none of these can be pink. So this must be blue, which means this can't be blue. That is dark. And we have all the regions there. We still don't have it for the green and the light differentiation, but we should be able to figure that out. 2 has to be here for the red, which eliminates 2 in the rest of the column. This is 2 here. So that eliminates 2 from being here. So that means 2, again, 2 cannot be here. No 2 here, which means 2 has to be there. We're guaranteed a 6 here for the reds, which eliminates, well, we don't have a 6 here. Okay. 2 cannot be here. This is blue. It can't have 6 or 9, so that's 4, which makes this 5. This has to be a 1, 7 pair, which eliminates 1 and 7 in the rest of the column. So where's 7 in yellow? It must be here. That's 7. We can't have 1 in pink, so this is not 1. We have a 1, 7 pair in row 7, which eliminates 1, 7 in the rest of the row. No 7 here, it's 3, which eliminates 3 here. Where's 3 in row 5? It has to be here. That eliminates 3 in the rest of the pink region. This is 4, 6 is a pair, which eliminates 4, 6 in the rest of the pink region. So this can't be 4, 6, it's 8, which makes this 9, which makes that 8, which makes that 7, which makes that 9. 5 eliminates 5 here, so 6 and 5. 6 eliminates 6 here. This can't be 4 either, so it's 1, which makes that 4, which makes that 6. 1 eliminates 1 here, so it's 7 and 1. Okay, 4 and 9 eliminates 9 here, so that's 1. That means no 1 here. This is not 1 or 4, it's 8, which eliminates 8 in the rest of the row. No 1 or 3 here, so this is 4. That means no 4 here. 3 eliminates 3 here, so it's 9, which makes that 3. 9 eliminates 9 here, so it's 5 and 9. That means 5 cannot be in green, so this is light. This cannot be light, so that's green, and we have the boundaries there. 8 eliminates 8 here, so it's 6 and 8. No 3 or 4 here, it's 1. These can't be 4 anymore. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 2 and 3. 2 eliminates 2 here, so it's 8 and 2. This can't be 8 or 9 anymore. It's 4. No 4 or 9 here, so it's 8, which makes this 9. 6 eliminates 6 here, so it's 4 and 6. 1 eliminates 1 here, so that's 7 and 1. And that's the solution to this puzzle. Interesting. Yep, very hard. Sounds about right. It's the logic behind it isn't too bad, but the execution can be pretty hairy. So it was a interesting little puzzle here. I always like chaos constructions, so it's always interesting to me to find these different chaos construction rule sets. And I get to color a lot. And I really like coloring, so. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.